do I call that bad boy? And yes, B is the center. If any, that I should have told you that. B is the center of that circle. So what do I call angle B? What's that name of that angle up there at this point in the unit? Let's roll twos. Bailey, what's that angle called? That's called the central angle. Excellent. All right, that's a central angle coming from the center. And how do you find any central angle? What's it always equal to? Central angle always equal to, let's go 10, Henry. Good. It's arc measure, which in this case would be CA. Good. So that's one type. The other type you're familiar with inside a circle is angle F up here, and that's called angle F. That is what type of angle, Vinny? Inscribe. Great job, everybody, so far. And how do I find it? We should know the rule by now, how to find an inscribed angle. What do I do to find angle F or any inscribed angle? 10, going back to Henry.
It's arc.
Half its arc. Yep, so half of the measure of arc, E and G. Okay, so those are the two you're familiar with. I'm going to introduce a third one right now. So if you go to your notes, here's the third one. Everyone in my diagram up here, can you take a look at angle ACB? And I'm just picking that. I could have picked, take a look. I could have picked any of these four right here. I just chose ACB. All right, I could have picked any of those four, but I'm going to pick ACB. Is it a central angle? Absolutely not, because C is not the center. Is it inscribed? No, absolutely not, because C is not on the circle. This is an angle we have never talked about before. Here's the name I'm going to give to it. It's really not mathematical, but it's the easiest way, and I stole it from a teacher years ago, so I don't want to take credit for it. I call it a floater angle. A floater angle. And maybe you can see why. Why do I call it a floater angle? Because that's exactly what it's doing. It's not connected to anything. It's just kind of floating in the circle. All right, it's not connected to anything. So I call that a floater. So you have central, inscribed, and now a floater angle inside a circle. Angles inside a circle. All right, now how do I find the floater angle? Here you go. Here's your big fact for today. The only fact I'll give you, how to find a floater angle. It's very wordy, but once you catch on, the numbers will go quick. You ready? You take its connected arc. All right, you take its connected arc, so whatever arc it's connected to, we take that measure, add it to, yeah, we got to add arcs on this one. Ready for this one? We add it to its vertical angles connected arc. And I told you it's wordy, sorry. Not really though. That's all right. So we take its connected arc measure plus its vertical angles connected arc. Oh, I'm not done yet. Then we got to take all of that and cut it in half. Divide by 2. Go back up to angle ACB for me, that floater angle we did. Substitute in the arc measures now, that where we would have to add and divide by 2 now. Substitute in the arc measures. All right, I'm going to turn this over to you guys. Okay, let's go here. Stellan, angle ACB belongs to what arc? What arc is it connected to? Okay, so everyone in here, I would take the measure of arc AB plus, now look at the vertical angle and tell me what arc the vertical angle is connected to. Stellan again, vertical angles connected to what arc? DE. Good, so I would add DE, and then I'd finish it off by just dividing by 2. That's how you find a floater. Okay, that's how you find a floater. Its connected arc plus its vertical angles arc divided by 2. All right, let's use it now. Let's use it. I'm going to turn this all over to you guys. This point of intersection is not the center. All right, this is not a central angle. It is a floater angle. All right, so don't assume that that's the center. And the answer is 88. No. All right, it's a floater. All right, so here we go. Let's do this. Where am I going here? Not here. All right, let's go up. 1, 2 for 2. There we go. Dylan, give me the floater angles connected arc. 88 plus, how about its vertical angles connected arc? 86, and we're going to divide that by 2. What are you doing going to the calculator? If you get an 88 on test 1, an 86 on test 2, and I ask what's halfway in between, what's your average? Oh yeah, that's how, okay, yeah, he's got a point. That's how the numbers work. I didn't think about it that way. 87. There you go. Oh yeah, I'm getting it now. I get it now. Some of you might get it 8th period. Who knows? All right, next up. I could give you the floater and ask for the arc now. I could give you, everyone sees 65, not central, not inscribed, it's floater. So I'm giving you the floater. So I'm going to start this off with 65 equals. I already know the floater. All right, what's it equal to here? Let's talk. Whew, where are we going here? Drew, the floater angle belongs to what connected arc? 100 plus, what about its vertical angles connected arc? How big is that one? What do we got here? Lauren? The vertical angle to 65, what arc does it belong to? There you go. Plus x and divided by 2. How would some of you algebra studs solve that? Probably getting rid of the 2. How? Yeah, multiply both sides by 2 to get rid of it. Boom. Boom. Good work. What do we got there? $1.30. 100 plus x. So x it ended up being 30. Woo! All right, hey, good work. Anybody issues with finding the floaters? Because we're going to up it now. Up the difficulty. We're good? Woo, let's go. Let's go then. Third one. I got numbers in a ratio. I'll get to that in a second. Find x. Everyone look at angle x first. Is it central? Is that a central? Nope. Is it inscribed? Nope. We identify it as a floater then. So the first thing I want to do, forget about numbers or substituting in anything. How would you find angle x? Using what arcs here? Give me the arc names before we substitute in degree measures for them. Where are we going? Henry, what arc is connected to the floater angle x? I'm going to put ABC. Yep. So arc 8, we're going to take arc ABC, add that to its vertical angles arc, which would be which one up here? 19. Where are we going for that one? I'm going to keep going. There we go. Cormac, what's the vertical angles arc? DFG. Yep. And then we're going to divide that by 2. So that's our goal. I need to get those 2 arc measures so I can substitute them in. All right, it's been a while since we did this. Anytime I have numbers in a ratio, anybody remember we apply what to them? X's to them. We're going to apply X's. So at ABC, find that arc. Arc ABC, we're just not going to put a 2. We're going to put this is going to be 2x for that arc. We apply X's to them when I see numbers in a ratio. Let's keep going. Arc CD, we're not going to put a 3 with it. We'll put 3x. DFG, we're not definitely going to put a 1 there. We'll put 1x. And then finally finishing everything up here, AG, don't put a 4, put 4x. Those aren't the values, though, I'm substituting in. I need degree measures, like 82 degrees, 50 degrees to substitute in. What can I do with all 4 of these to set up an equation to solve for x now? What do you know about all 4 of these arcs? Add up to 360. There you go. Solve for x now. 2x, 3x, x, and 4x all add up to 360. Solve for x, substitute it back in. Go ahead. All right, we're all getting x equals 36. Substitute it back in and find the arc. Now look, we only need 2 arc measures, but if you want to feel warm and happy inside and find all 4, go ahead. It doesn't matter to me. I just need 2 of them though. All All right, so I plug it back in. Let's see, arc ABC, 2 times 36. Everyone should be getting 72 for that arc. And then the other one I need is DFG, which is just X, so that's going to be 36. If you want to find the other two, makes you feel warm inside, go right ahead. All right, so substitute it back in now. So that floater angle will equal to 36 plus 72 degrees, all divided by 2. That's how you find a floater. $54. All right, all good. All right, I'm going to let you take a little break right now, get some air in you before we tackle this beast. All right, before we tackle this one here. You need to stretch out, whatever you need to do. It's not gonna be pretty here coming up. Anybody got anything exciting coming up? No, today? Nothing? Just your typical Wednesday?
Dentist appointment.
What's that?
I have a dentist after school.
Wow, that is something I would be looking forward to.
I can't wait.
Routine cleaning, or we got a cavity to fill?
No, routine.
Okay, good. Hopefully, they don't find any cavities, right? Because then, put the needles in there. And it's not fun. Not fun. Do you get to choose the toothpaste?
Yeah.
Really? You do? They still do that? I don't get a choice anymore. What do you usually go for? Bubblegum? Grape? Grape, darn right. It's probably on the top. If you just go for like the chocolate weird type, you're just a freak, honestly. Let's be honest. Who's putting that in your mouth? All right. All right, well, good luck, Alexi. I expect a report back tomorrow. Okay. The worst part is the scraping.
Yeah.
They just keep scraping. You're keeping your mouth open that entire time, and your jaw is just killing you. The best part, though, is they put that suction thing in there. It's like gone in seconds. It's amazing. Go on. Tongue goes with it, too, sometimes. Yeah. All right, we ready to roll? All right, these are what I call king-size circle problems. This is going to test your ability on all the circle facts we've done. All of them. Starting from day 4, all the circle facts. Just not a floater angle. All of them. And here's what I want you to do anytime you start tackling a king-size circle problem. Find every arc measure first. I do not care what parts A through whatever are asking you for. Don't even look at it. What I want you to do first to have the best success possible is find every arc measure you can. Find every arc measure you can, because I bet you your success will be very high if you can do that. Don't look through A through E here. Who cares what they're asking for? Help me find all the arc measures first. So let's look at what's given here. AEH, find that arc. A to E to H, they're saying is $110. However you want to label that. All right, that's 110. Here you go. Here's what I'm going to do. 110. A to E to H. Boom. However you want to do it yourself. Arc AG is 80 degrees. So I throw my 80 degrees on arc AG, and here come the numbers in a ratio again, right? AE to EH is 2 to 3. So it looks like on arc AE, I'm not going to place a 2. I'm going to put a 2x here. And on EH, I'm not going to put a 3, but I'm going to put a 3x. Don't look at parts A through E. It's only going to make you nervous. Look at this diagram. It's nuts. All right, it's intimidating. Find the arcs first. Find every single arc you can. Can we start here? I think we can find arc AE and EH, right? Do 2x and 3x, add them up and set them equal to not 360 this time, but $110. All right, let's do it. So 2x plus 3x equals 110. 5x equals 110. And as I divide both sides by 5, looks like x comes out to be 22. Not degrees, but just 22. All right, substitute it back in right now, and let's find AE and EH. All right, AE times 2, that's going to be a 44-degree arc. 22 times 3, EH will be a 66-degree arc. I didn't ask you to find 2. I asked you to find all of them. So let's go to arc HB now. How am I going to find that? That's blank. You can find it. And this is your first one, so you probably don't even see it. I want you to look for this every single time. AOB. AOB. What's that bad boy called? And doesn't it split the circle into 2 semicircles, which measure how many degrees? You can find arc HB. Because we already know this arc is 110. The rest of it's got to add up to 180. So HB, 7D. Found it. GB. That's the only other arc I don't know. Find it the same way. Right? Diameter. Breaks it up into 2 semicircles. So if one piece is 80, what's GB going to be? GB? 100 degrees. Watch how easy this becomes once we know all the arc measures. All right, we're ready now to go A through E. All right, part A. Find the measure of arc GB. Oh, already found it. Done. 100. Part B. Oh, you want me to find arc EA? Already did it. 44. You will find that if you find every arc first, you probably already know the parts A and B automatically. All right, now here's where the fun begins. All right, digging deep now. Do we know our facts or not? EFA. Everyone find that angle on our diagram. EFA. Everyone see it? All right, also, I could also call it GEB. Right, everyone's good there. I could call it GEB. Is that angle inside or outside the circle? EFA. I'm sorry. Disregard what I just said. I'm an idiot. EFA, inside or outside? Inside. So that means it's one of 3 types. If you told me that angle's inside, it's one of 3 types. Is it central? Nope. Is it inscribed? Nope. That means it's got to be what type? It is a floater angle. And how do I find floaters? I'm going to add up 2 arcs. And now we'll slow it down a little bit here. Henry, here we go, big dog. 3 times today. Angle EFA belongs to what arc? What arc is connected to it? Which is how big? 44. So I'm going to take 44, add it to its vertical angles connected arc. Take a peek here. Where are we going here? Jared, what's the measure of its vertical angles arc? Great job, 100 degrees. And I'm going to divide that by 2. So arc EFA is going to be, what do we got there? 72? Add that up, right, and divide by 2. When doing king-size circle problems, please put that number in your diagram too. You may need it down the road. You may need it. So EFA is 72. Let's keep going. FEB. Everyone find FEB? This is what I meant earlier. We could also call it GEB. Inside or outside? Inside or outside? Okay, if you're telling me it's inside, it better be one of 3 types. Is that angle a central angle? Central angle? Nope. Is it inscribed? Ding, 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 we got it. But we don't know it unless we know our facts and vocabulary. That's an inscribed angle, and you guys told me earlier in class that I'm going to take half an arc when I do that. So what arc am I going to take half of? What am I going to take half of? This angle right here, FEB. What am I going to take half of? Half of, Lily? 100. Great work. So that should be 50 degrees. Label it. I don't know. I may need it. 50. And are you ready? OHD. No calculator needed. Just knowing your stuff. What's OH? What's OH? Radius. Everyone hear that word, radius? What is point H called? Point of tangency. What happens when those two meet? We're done. Just by knowing the fact. No calculations, nothing. That's a right angle. OHD. Radius drawn to a point of tangency perpendicular. Woo! Welcome to the king size circle problems. Questions? All right, one king size doesn't make you great. Absolutely not. Let's go to this beast. Again, look, it wants me to find two angles and an arc. I don't care. I want to find all the arcs first. Maximum success will be achieved when you find all the arc measures first. Here we go. You read through. Don't overlook this. Read through everything. AP bisects BAC. Can you tell me what two angles are congruent then? AP, that line segment, bisects angle BAC. So what angles can I put arc marks on to show you guys they are congruent? BAC getting bisected. What two angles are congruent up here? Lauren, going back to you again.
BIE and CA.
Great job. Those two going to be congruent. Good. All right, let's keep reading. I got a tangent line. Perfect. Ooh. Numbers in a ratio, but now they're to angles, aren't they? They're to angles. So on angle ACB, find angle ACB. You're not going to put a 4. You're going to put 4x right there, right? ACB, 4x. Let's keep going. CAB. That whole angle is 3x. And then finally, angle ABC. Don't put a 2, put a 2x. Put a 2x. All right, what can I do with all three of these? I don't want to add them and get them to 360 this time, do I? I want to go what? Add them and get them equal to $180 because it's in a triangle. All right, so let's do that so I can substitute them back in. 3x, 4x, and 2x all equal to 180. All right, everyone's getting 20. Substitute it back in. Let's find the angles in the triangle. Let me start on angle ABC, angle B. Substitute it back in. You get 40, everyone? 40 degrees. All right, how about that angle that got bisected? That's going to be 20 times 3, so 60. Bisect it. Let's put 30s on each now. All right, let's put 30s on each because now we know that angle was 60, but it's getting bisected, so I'm going to put 30, 30. And how about the 4x angle? That looks like it's going to be 80. Again, still, I don't care what they're asking me to find. Find the darn arcs first. All right, let me go around here. These angles inside the triangle, they're all what type of angles? 80 degrees, not acute. I'm not looking for like acute, like angle C, angle B. What do we call those angles inside a circle? Those are all inscribed. So you should be able to find the arc, right? If angle C is 80, how do I find arc AB, the one it's connected to? Take half of it? No. What do I do with the 80 to get to the arc that it's connected to? Double it. So 80 times 2. That should be 160. Everyone, yeah? Because it's connected to an inscribed angle. How about arc AC? Arc AC is going to be 80. Double it. All right, now what about, let's go now, arc CF. Arc measure for CF, 60. And the same thing's going to go for BF because it's across from a 30-degree inscribed angle. All right. So we found every arc measure you can. Now, again, just watch how easy these problems become now. All right, first part, find angle ABC. Oh, guess what? We already did it. It's 40 degrees. Oh, you want me to find the measure of arc BF? You got it. I already did it. I don't have to think about it and get nervous. It's 60. All right, the one we are going to have to do work for before we end it today. How about the measure of angle BEP? All right, kids, BEP, inside or outside? Inside, ready? Is it central? Central? Central angle? No, come on. E is not the center. Is it inscribed? Nope. So it's got to be my good old floater angle. All right, tell me what two arcs I'm going to add up and divide by 2 here. BEP, what arc does it belong to? BEP, what's its arc measure? Oh, Henry! There you go. Which is? 60, good. Plus vertical angles connected arc. What's the measure of BEP's vertical angles arc? What do you got for me there? What's that measure there? Jared, that group back there. 80, there you go. You get a 60 and an 80, halfway in between. That arc's going to be 70. Not done. Not done. Look, you may freeze or forget a circle fact. Let's just say you totally blanked. Did not recognize it was a floater angle, or maybe forgot the floater angle fact. Still not an excuse. Watch. How many angles do I know in that triangle? 2. That adds up to 70 degrees, meaning the third angle has to be 110. And I am asking for the angle next to it. What's the relationship? Supplementary. 70 degrees. So what I'm telling you is never give up on an angle. You may think there's no way in heck I'm going to find it. Use some other geometry. Like there's 180 degrees in a triangle. Okay? Never give up on it. Just because you don't know the fact or think there's no fact exists, you're probably going to be able to find it by finding more angles around it. What do you got?
You also use the other triangle and find
The other triangle. Oh, this one right here, and say they're vertical. There you go. Another way around it. Right? Don't give up because you don't think there's a fact. That's my point here going into tonight's homework. Don't give up on it.